when I began with competitive programming, I remember that it was around 3 weeks or something like that, and I started seeing some fancy keywords in the code of other people that I was following, and I realized that I really don't know C++ that well, and it really became very overwhelming for me to step into that and see what that is all about, because there were so many fancy keywords like pair, vector, set, multi-set, and I was like really overwhelmed about what this is all about. But I remember that at that point of time I really wanted someone professional, someone who is like really great at competitive programming, to teach me just about how to use them and what are these various things, so that I can get started with my journey to become a good programmer. And I remember that I just postponed all these things because I was not having some good mentor. I was just trying things on my own, and they did work out really well. And but now I'm here. I did a lot of hard work to cross 2000 plus rating on Codeforces. I did a lot of submissions on Codeforces, solved a hell lot of problems, and I realized that C++ STL, or all these fancy keywords that I used to ignore initially, are super useful. Without them, like, it's really difficult to survive in a programming contest and also clear coding interviews, because these are some of the things which are so easy to use that people expect you to know them, and the solutions won't pass if you don't use them. So today's video is about C++ STL, and I hope you will like it. Hey guys, this is me Rachit. Welcome to yet another video. Today I want to talk about C++ STL. It's a very important topic because C++ STL is about all the data structures and algorithms which are already implemented in C++ internal library, and we can leverage them as programmers of C++, as developers in C++, and we can use them, which are predefined, which are pre-implemented, and we can use them to make our solutions more powerful. We can use them to pass the various time limits of the problems that we want to solve, and it's super awesome. And I think it's very important, because without this, I don't think you can clear the software interviews. Sets, maps, all these things are something which are used so much frequently, and if you don't know how to use them, you are going to waste a lot of time. People don't realize that once they are in the coding interview rounds and they have to use maps, set, they don't remember the syntax, how to use them, they waste so much time and confidence, and ultimately they are not able to submit the solution. And if you don't use C++ STL, then maybe you are going to implement those functions yourself, and that is very difficult and not going to happen in the time limit that you are having. So I would recommend that please invest a lot of time in C++ STL, so that you are very much familiar about how set works, how vector works, how you can sort a vector of structs, how you can maintain a set of structs, and things like that. So in this video, what I wanted to do was quickly talk about and get you familiarized with the various C++ STL offerings that we have. So to begin with, let's start with vector. Vector int is nothing but an array or a list of 1 2 3 4, let's say. So let's say we are having four numbers, 1 2 3 4, or let's shuffle them up. Let's make this 11, let's make this 2, then we have a 3, and let's have 14. Of course it's throwing error because I have to include the library for that, hash include vector, and this will go away. Alright, so I have my vector. Now how do I access an element of the vector? Let's say I want to access the second element. So in terms of zero-based indexing, it is the index 1 that I want to access, and I can do something like cout a1. And so this is how you can simply access the second element of your vector. And similarly, you can do a lot of things. Let's say you want to sort this, so you can do a.begin, a.end. I want to sort from the beginning till the end, and this will do that. Alright, so sort is again not there, it's throwing an error, so let's include this algorithm. Right, so now this should go away. So now this is doing the sorting in n log n time, and if you don't want to use C++ STL, then you will be implementing merge sort, which takes so much time. So this is why you should be really familiarized with how you can do a lot of things in C++ STL. It saves you time, it makes your code more powerful. Alright, so that's good. Now let's say if this is sorted, so this looks something like 2, 3, 11, and 14. And now since it's sorted, I can binary search on it to find out in log and time about whether an element is present in it or not. So again, that is something that we don't have to implement, it's already there. We can do something like bool present equal to binary search and we can say a dot begin, a dot end. This is the search space where we want to do binary search from starting till ending, and I am interested in finding whether 3 is there. So one is this. Another condition is when you check for a number which is not present, that's another case. So present binary search, let's check for value maybe 4. So now this should be false, and of course this should be true. We'll quickly check if these things are working as they should be working. So now our vector is sorted. That's awesome, but what else can we do? What if I want to sort this array in descending order? Or what if I want to insert more elements in this? So I can do something like push back, and I can insert maybe 100. So my array is still sorted, which is great. So I can again check if we have this number now. So I can do a binary search, a dot begin, a dot end, and there goes 100. All right, that's awesome. This should also be true. We will check that. But what else can we do? So now the array contents are something like 2, 3, 11, 14, because that's what we did above. Now we also inserted 100. So this is the array contents that we have. And now let's say I am interested in finding out. Oh wait, let's make this a bit more interesting. Let's insert 100 a couple of more times. So now the array becomes nothing but we have 100, 100 and 100, and let's then insert 123. So let me quickly do that. All right, so now this is what the array looks like after this point. And now let's say I'm interested in finding the first occurrence of 100 in this, or I want to get the iterator to the first occurrence of 100 in this. So once the array is sorted, what you can do is you can use a lower bound on our array, and what we are going to do is do a lower bound on 100. And what lower bound returns is an iterator. Iterator of what? Iterator of vector int iterator. And if you are thinking this is like really getting complex, don't worry about that. We are going to simplify this a lot. So yeah, I'm doing lower bound on the whole array on the value 100, and this should return, or this should return the iterator pointing to this 100, because lower bound is nothing but give me the iterator to the first element which is greater than or equal to. All right, and similarly we have let's have another iterator. We can do also an upper bound on this, which now this will give the first element which is strictly greater than the number that you are performing the upper bound on. Now since we are performing lower bound and upper bound on 100, in this line it will get the iterator to this 100 because this is the first element greater than or equal to 100, and then it2 is 123 because this is the first element which is strictly greater than 100. So don't get confused with lower bound and upper bound. They both are something which are greater, but lower bound is not that strict, so it's greater than and equal to. So if this is the case, what I can also do is simply print the contents of it and it2. All right, let me do that. And another interesting thing that we can do is print the difference between it2 minus it1. And essentially this is nothing but 4, because iterators in vectors are random. What that means is you can simply perform arithmetic operations on them in constant time. So basically you can do subtraction between two vector iterators, and this will take O1 time. All right, so what is the benefit of this? So lower bound and upper bound on a sorted vector is done in log n time using binary search. So again, this is a great capability that C++ gave us. Like, it's a very common thing in coding rounds that you sometimes have to get the first element which is greater than or equal to given element, and you don't have to implement that now because in log n time you are just getting that for free now. So these are some of the out of the box capabilities that C++ offers us, and we should be definitely able to use them. So what are the various things that we can do from the things that we have studied till now? So we can sort a vector of integers, and we can do binary search to find out if any element is present in that or not. And if the vector is still sorted, what we can do is we can also perform lower bounds and upper bounds on some int value, so that we can get the first occurrence, or we can get the first element which is strictly greater than that, or first element which is greater than or equal to that. And of course we can also get the count of a number now, because if you want to get the count of 100, simply perform an upper bound and lower bound and just take the difference of those two iterators, because the IT2 is at 123 and IT1 is at this position, and their difference will be 4, so you know exactly how many times 100 is occurring. So that's great. Like within 2-3 minutes we learned a lot of things, and that's awesome. All right, so let me first quickly go through this so that it doesn't get overwhelming for you. Let me first build this and let's see how this goes. All right, so we are over here, and as you can see 100 and 123 is printed, so IT2 is at 123, IT is at 100. Now let's also print this, and you can see 5 has been printed. So the number of times 100 was there was 5 actually, to be honest, right? Yeah, so I have inserted 100 here and then 4 times here, so this array is nothing but this, to be honest. So yeah, this is fine, this is printing 5 because 100 is occurring 5 times. Awesome. But now let's also, just I would like to show you in the watch how things look. All right, so we have an array A. Let's see how this looks like. So the vector A is having size 10. The first element is 2, then 3, then 11, then 14. Then we have 100, 100, 100, 100, and then 123. Then we have this iterator right over here. Let's see what this is holding. Alright, the value in iterator IT is 100 that we were expecting. And it's a pointer, as you can say. Iterators are sort of pointers, and it's pointing to the value 100. And this is nothing but the first 100 that is right over here. Now let's also have a look at IT2. As you can see over here, the pointer is this, and it's pointing to 123. That's awesome, I guess. And now let's move forward. Okay, I will quickly stop this, and we are back. So this looks good. Let me decrease the font size. So now the things look good. We can perform a lower bound, upper bound. Fantastic. But what if I want to sort this vector in reverse order? So what we can do is, there is an overloaded function, and you can pass nothing but a comparator function right over here to control what is the ordering that you want. So let's pass some comparator function. Let's call that f right now, and we can define a comparator function right over here in global space. So comparator function is nothing but it returns true and false. And if we want to sort this in decreasing order, what we can do is we can say return x is greater than y, and now this should sort the array or the vector in descending order. And let's quickly print that. So how do we print the vector? Again, we can use iterators to print the vectors. So you can do something like iterator it3. Then we can do something like for it3 equal to a dot begin, it3 is not equal to a dot end, it3 plus plus, and we can simply print star it3. So this is how you can print a vector, and now things should be good and the contents should be reversed. Let's have a quick look if it's working or not. So as you can see, the vector is sorted in descending order, and that's great. We have just learned how to do that. But here is another interesting thing that we can do. So I believe that this iterator concepts can be like really difficult to understand and really hard to type. So C++ is like really emerging now, and just to print the vector, what we can do is simply do something like for int x in our vector A, we just want to print x, and this will take care of everything. And instead of vector int iterator over here, we can simply say auto, and C++ is intelligent enough to see that the lower bound is being performed on a vector called A, and it's a vector of ints. So of course this is an iterator of what? Iterator of a vector of ints. So this is how C++ really saves your time now, and things look really, really awesome. So now we don't need this IT3, and just to print we can do something like for int x in a cout x, and that's awesome. And if you do something like x++, things won't really change the vector contents. Like your vector values will stay what they were, like 120, 300, 100 and so on. But if you want to really also iterate on your vector and simultaneously update the values, what you can do is iterate by reference and just add an ampersand right over here. I will just increase the font size to focus on that, and you can add an ampersand just to iterate by reference. And now any changes made over here to x will be applied back on that particular element of the vector. So if I do this now, and let's just delete this and simply then just copy paste this right over here, and now let's iterate normally and simply print the contents, and now you can see the values will be updated. So let's quickly try to run this and see if it's working. So as you can see now 124, 100, 101 1 is incremented, and this is how we can iterate by reference on a vector. Alright, that's awesome. Now the drawback of this is, like, we are first inserting elements and then sorting, and only then we can perform lower bounds, upper bounds and things like that. What if we want to insert elements in random order? Like I want to insert 14, 10, then 1000, then maybe 1, then maybe -1, and then maybe 10,000 and things like that. I want to insert numbers in random order, and after each operation I also want to do queries in between. Like I really want to know the first number which is greater than some particular number. So to handle all those cases, what we have is called a set. And what we can do is, I will just quickly remove all this, and I will move this to a vector function. Let's say void vector demo, and everything is right there, so we don't have to worry about it. Now let's talk about a set demo, and let that be in this function. Alright, so again, to sum up, in vectors you can insert numbers at the end using push_back, and then once your array is sorted, which you can do using the sort function right over here, you can perform various functions like lower bound and upper bound, which in just log n time, where n is the number of elements in the vector. So in just log n time, they can give you the first element which is greater than or equal to x, or the first element which is strictly greater than x. And you can also check whether a number is present or not, and all those kind of things. But this only works when the array is completely sorted, and sorting takes n log n time. So now let's say your array is sorted, and now you insert some number, or you insert some 3-4 numbers, and then you have to again sort your array to again efficiently answer queries about lower bound and upper bound. But sorting takes n log n time, so that's something we want to avoid. We want some data structure where we can keep on inserting elements also in log n time, and keep on performing options like lower bound and upper bound as well in log n time. This is what we want. So to do that, we have set. Set is nothing but set int s, let's say. Of course, set, we have to include it. Let's go up and include set. Alright, so now to insert a number in set, we can do something like s.insert1, s.insert2, and so on. What if we want to so what is happening over here? So set internally maintains the ascending order sequence in these numbers. So now if I insert s.insert, let's say -1, and then let's insert, let's say -10. So now if I iterate on the contents of my set, it will be in ascending order, which is -10 will be coming first, followed by -1, then 1 and 2. Let's quickly check if it's working. So for int x in s, cout x, and then we can do something like cout endl. So let's quickly check out the set demo from our main, let's call that, and see if it's working. Alright, as you can see, -10 came first, -1, 1 and 2. So this is the beauty of set, and each operation is in just log n time. So no matter if so this is where set becomes powerful than vector. In vector you can simply insert at the end, and if your vector was sorted and if you insert some number, it will disturb the ordering of the vector unless and until the last number that you're inserting is the max or greater than the max of the present vector. So this is where set comes into picture and really dominates it. Like the insert operation is just log n time. So at any time your complete collection is sorted, and you don't have to perform a sort operation explicitly whenever you are inserting some new number, which is the case in vector, and sorting is in log n. So yeah, this is why I love sets really well. They are just very cheap. Log n time is like really great time complexity when we are talking in terms of competitive programming. So that's fine. Now what else can I do with sets? To be honest, you can do a lot of things. So let's now, so now the contents of the set are -10, -1, 1 and 2. Now let's say I'm interested in finding whether -1 is present in a set or not. So what we can do is we can say auto it equal to s dot find what? Find -1. What it does is it tries to find if -1 is present. If it's present, it returns the iterator to that. So it will now pointing, so it after this line will be pointing to -1 over here. And if some element is not present, this will return the iterator s dot end. So what we can do is if it is equal to s dot end, it means the element was not present. Cout not present. And otherwise we can simply say it's present. In fact, we can also print the value by cout star it endl. Alright, that's great. But what if I want to find the first number in the set which is greater than -1 or which is greater than 0? How do I do that? So if we want strictly greater than that, we can use upper bound. And how that works is auto it2 equal to s dot lower bound. Remember that initially in vectors, lower bound was a separate function and we used to pass the a dot begin, a dot end over here. But in set, since it's already sorted, it's always sorted, the class itself is having the function lower bound exposed to the users. So now we can do s dot lower bound, and we can simply do let's say -1. So this will give me again what? Iterator to the first element in the set which is greater than or equal to -1. So this will give me exactly this. But let's say if I was interested in finding strictly greater, so I can do something like upper bound. So upper bound of -1 is 1, and upper bound of 0 will also be pointing to 1. In fact, we can print the contents of both the iterators just to see if we are right or not. And this should print nothing but 1. Another interesting scenario over here is what if we try to find the upper bound of 2? Now upper bound of 2 does not exist in a set. So what will it do? It will do nothing but return the, any guesses? What will this do? Of course it will return the iterator s dot end, because it's something that he was not able to find within the set. So there was no iterator for which upper bound of 2 exists, and this will get executed. Oops, sorry, can't find, something like that. Alright, so if everything went well, I think we will see all these things that we had just implemented right over here. Now let's quickly run this. Alright, so we have printed the set. It's -10, -1, 1 and 2. Let's come down and s dot find -1. Let's see what it's returning. It's returning iterator and it's having the value -1. Awesome, because we tried to find and it found it. So it goes to else and it says present. It prints the value. Let's go to the screen and verify that. Yeah, as you can see, present -1. And now we do upper bound on -1 and upper bound on 0. So this is pointing to 1, and it3, let's see, is also pointing to 1. Awesome. So as you can see, 1 and 1 are printed right over here, and we are over here trying to do the upper bound of 2. Let's see what is it. Oh, IT4 is pointing to end. That's awesome, and it should print. Oops, sorry, can't find something like that. Great. So our code run exactly as we wanted, and now we are in a position where we can have some numbers, have them in some sorted order. You can insert any new number. It will just cost me log n time to insert that number, where n is the present number of uh, integers in my set, and my set will always stay sorted, which means I have the capabilities to find the next greater element in just log n time, which is so damn awesome. So this is why I really love sets. This is why I really love vectors. I feel sets are really very powerful than vectors, and these are some things that you should definitely know. Let's also quickly do a demo on map. Thing that I wanted to do over here was give you a brief overview about the C++ STL and how we can use it to do really great things. So I hope I hope this video is useful to you. Let me know in comments. I would really like to work on feedback and try to make more such videos. So moving on with the map. Map is what? Map is, as the name says, mapping something to something. So what we can do is map int to int and call that a. Of course, we have to insert map. Let's go right at the top and include map. So coming back, yeah, so map int comma int a. Now what we can do is we can say a of 1 is 100. We can say a of 2 is -1. A of 3 is 200, and so on. We can do any random thing that we want. We can do something like this is equal to 0, or wait, 0 is not interesting, 1. So we can do something like this, and we are mapping into int, and we can do something like map char to int as well, and let's call that as count. And let's say we have a string x equal to, let's say, Rachit Jan. I'm so self-obsessed maybe. And then what we can do is iterate on our present string. So for each character C in my string x, I want count C plus, and now I can safely know how many times a character occurs in my name. So now I can do something like C out count count of a, how many times a occurs, and then maybe also how many times z occurs, and I want to find that. So again, map is nothing but, so map is again something like set, and in log n time you can map something to something. So all these statements right over here take log n time, wherein is the present size of the map or the present number of items that the map contains. So each these mappings take log n time, and then you can retrieve the value mapped to the character a again in log n time. So I really love the log n time factor, and map can do wonders. In this case, we just used a map of char to int to find out the frequency of any character in a given string in log n time. So of course, building this map takes the time proportional to the length of the string. But once we have done this, we can at any time in log n time tell how many times a character is occurring. So these were the basic cases about set, map, and their time complexities. I hope it gets you started with C++ STL. It's not really that difficult, and it has so many use cases. Like I simply just taught you over here, like it can map into int, string to int, char to int to char to int, and so many things, so many permutations are possible. But there are so many, realizations or implementations where we leverage these data structures to really solve really great problems. And that's the whole intent. So I will quickly try to close this video just by showing you a very powerful implementation that we can achieve using C++ STL. So all right, I will do over here now, and what I'm going to do over here is solve a very big problem for you. Now let's say the question is, I will give you queries like add interval x to y, right? For example, I will say add the interval 2 to 3, right? At 2 to 3, I can say add maybe 10 to 20. Maybe I can say add 30 to 400. And then I say give me the interval which contains the point 13. Give me the interval that contains the point 13. So in this case it will be 10 to 20. And now we can, now just to make this case easier, let's say I am saying the add function will always be something which does not overlaps with the previous intervals or gets merged. So I will never say something like 399 to 450. So because this will merge with this to generate one overlapped interval. So I won't give you such complex queries. I will always ensure that whatever interval I'm inserting is like really out of all those complex cases. So I will say something like 450 or 401 to 450 because it doesn't overlap. And when I say give me the interval containing the point 400, you should give 30 to 400. Otherwise you should, if I say 401, you should give me this interval. So this is something that I want you to implement, and we can do this very easily using sets. So what we are going to do here is have a set of what? Set of pairs. Now pair is what? Pair of int comma int. This is my set S, let's call it. And let's insert the numbers first. I will comment this out. So now I am inserting pairs in my set. And what is pair? Pair is nothing but x comma y. So if I am declaring a pair of int comma int, 1 comma 1 is a pair, minus 1 comma minus 12 is a pair, minus 1 comma 14 is a pair, minus 14 comma 343 is a pair. So all these are pair of what? Int comma int. We can have pair of int comma char, then it should be something like 1 comma 3 and 343, then we can have dollar over here. So yeah, pair of int comma char is something like this pair, but what I'm doing is pair of int comma int. What I'm going to do is insert the pairs like this. So 2 comma 3, and then we have, so these are the intervals that I inserted in my set. And of course, as I have mentioned, set is always ordered in ascending order. So what does ascending order in terms of pair means? Let's try to compare two pairs. For integers, we know that 2 is less than 3. So we already know when we are inserting the elements, we can think about what is the order in which the set is maintaining that. But in pairs also, we can find that order in which they are stored. So 2 comma 3 is smaller than 1020, 1020 is smaller than 30, 400, and 401 comma 450 is greatest among them. So how does comparison between pairs work? So to compare two pairs, let's say a comma b and c comma d. So if a is less than c, we will say that the first pair, which is a comma b, is smaller than c comma d, and it will come before c comma d in our set. But if a is equal to c, then the comparison is done between b and d. So if b is less than d, then a comma b will come before c comma d. So this is how the comparison between pair works. And in this case, even if we do something like we insert it in random order, like 401 before, then maybe 1020, then 2 3 and 30 400. After this line, 2 comma 3 will be coming first, then we will have, I think, 1020, and then we will have 30 comma 400, and then we will have 401 comma 450. So based on how pair comparison works, you can easily say that first the pairs are ordered in their first index, which is the x coordinates, I would say. And if x coordinates are same for two pairs, they are ordered on their y coordinates. So in this case, since x coordinates are always different, 2 3 comes first, then 1020, then 30 400, and 400 450. So now let's say we are interested in finding some point, and what is the interval that contains that. So for example, if I say 21, so we know that 21 is not contained in anything. But let's say if I say 31, so we know that it's right over here. So what I can do is, I can do nothing but an upper bound. So if I do an upper bound on 31, comma, and I will add any value over here, I don't care about that, but I will generate a pair like 31 comma question mark. We'll see what we have to fill over here, but let's say we are doing an upper bound on 31 comma something like that. So of course it will give us the iterator to this. Strictly greater than 31 comma something is 401 comma 450 in our set, and we will go one step back and we come to this, and if this pair contains 31, then we can say that yeah, this is the interval that has it. Otherwise we can safely say there is no pair in our set which contains the given point. Let's try some other values. Again, let's try maybe 9 or maybe 12. So if we do an upper bound on 12 comma something, we will get iterated to 30 comma 400, because 2 is not smaller, because 2 is smaller than 12, 10 is smaller than 12, 30 is the first element greater than 12. So when we are doing an upper bound on this pair, we get 30 comma 400, and we go one step back. 10 20, does it contain 12? Yes, it does, and we are done. Boom. This is how it's working. Now let's handle some corner case, like what if we do something like 10. So now if we do an upper bound, we can also get 10 comma 20. So let's say if we are doing an upper bound on 10 comma 0. So what is the first element in our collection of set which is greater than 10 comma 0? Of course it's 10 20, because x coordinate is same, then we do the comparison in terms of y, and 20 is greater. So yeah, 10 20 is the first, you can say, pair in our set which is greater than 10 comma 0. So now we get iterated of this, and based on our algorithm we go one step back and we reach 2 comma 3, and our algorithm works, and it says that, and our algorithm fails as it says that 2 comma. So we go one step back now to 2 comma 3 based on our algorithm, and it fails miserably because it says that 10 is not contained in any interval, but it was there. So this question mark over here should be big enough so that we always get 30 comma 400 while performing upper bound. So we can do this, put this as int underscore max, so that now whenever we are performing an upper bound, we get to 30 comma 400, right? Because nothing can be greater than int underscore max. So now we'll always come to 3400, go back and just see if things are working out. So let's quickly, implement this and see if it's working. So if I want to check my point, let's say 30 or let's say 50. So this is the point that we are going to check. And how do we check it? It's easy. Auto it equal to s dot upper bound on what? So since our set is of pair int and int, we also have to perform an upper bound with passing in a pair of integers. I understand that the only thing we had was a single integer, but since our set is of pairs, we can perform upper bound on pairs, and we are filling in this value as int underscore max to leverage this opportunity so that we come to the next pair, in this case 400 and 450, and then we will simply go one step back, so it minus minus. So let's quickly derive that pair first. Current equal to star it. Now if current dot first is less than equal to the point, and point is of course less than equal to current dot second. So whenever we generate a pair, we can pick up the first value by current dot first, and the second value we can access using current dot second. So my point will be contained in an interval only if it lies between the first and second values of that pair. So you can say yes, it's present, and you can also print the pair current dot first, current dot second. Awesome. Else you can say the given point is not lying in any interval. Awesome. So now if things go well, this should run, but of course we have to handle some of the corner cases. For example, what if this point is nothing but let's say 1. So now when we do an upper bound, we get 2 comma 3, then we do it minus, we try to go one step back, and that doesn't exist. So that's where we fail. So if it is same as s dot begin, it means we can simply say the point is not lying in any interval because there is nothing we can go back. So we can do something like, we can simply return here itself, return. And if that's not the case, we can go one step back, and this will work like a charm. So let's try to see if what happens in case of 1, and then we will slowly see how things change based on different value of point. Alright, let's run this. Alright, we are over here. Let's see what our set contains. Size is 4. As you can see, the order 2, 3, then 10, 20, then 30, 400, and then 400, 1, 450. Notice that we inserted them in random order, but set is always ordered, and that's how it's storing it. So now when I do the upper bound of 1, int underscore max, it should return 2, 3. Let's see what it is having. Exactly 2, 3. Awesome. Is it s dot begin? Yes, it is. So it prints the given point is not lying in exactly this. So let's try to go back and update the value of point and see how this changes. So let me just quickly change the value of point. Let's change that to maybe 11. Alright, now let's try to perform the upper bound. Now this time we get 30, 400 because point is 11 now. Over here it's 1, but I changed it in this debugger value. So point is 11 now, not 1. Don't get mistaken by this value, okay? So yeah, point was 11. Upper bound, of course, 30, 400 it should have. Yeah, we go one step back. IT minus minus. We take the current. So what is the current pair? 10, 20. Now if we now 10, 20 contains 11, so we print yes, it's present, and we say yes, it's present in 10, 20. Awesome. All right. Now let's try for one last value. Now let me change the value of point to 400, as that will be a bit tricky. Now let's perform an upper bound, and we get 400, 450. Then we go one step back. We get the current pair, which is 30, 400, as you can see right over here. Then we check if 400 is present in that. Oh yes, it's present, and we print it over here. As you can see, yes, it's present, 30, 400. Awesome. That's also working. Now let's also try for 401, and we can close this. It's 401. Yeah, value of point is 401. Now I'm performing upper bound on my set. What will I get? So to be honest, there is no element greater than 401 and int underscore max. No pair is there, so it should return s dot end. Let's see what's happening. Yes, it's end over here, as you can see in IT. Then we go one step back. So we come over here, we take the current pair, which is 401 and 450, and the point value is nothing but 401, and of course it's present in that, and it should print that. Boom. So guys, this is how this is why I love sets, and you can see the power of STL. We just solved a very complex problem, and the best thing is all these operations, add operations, are happening in just log n time, and we are also giving the interval in just log n time. We are not iterating on the n intervals that we already have in our set just to find out what is the interval that contains the given number. Just in log n time we are doing everything, and that's the power of STL. I hope you liked this video. I hope you understood how to use set and map, how to use vector, how to sort it, how to pass a comparator function to sort them or control the order in which you want to sort vector, and things like that. I hope you like this video, and this is a series. I will try to make more videos, try to go into more details and talk about the other offerings that C++ has, like unordered map, unordered set, and they have better time complexities as they are using hashing. But yeah, I mean, this is a long journey, and I hope this video was useful. I will see you next time. Let me know in comments if this was useful. Bye bye.